today we're looking at ogives and percentiles. So sometimes people say ogives. It's ogives as far as I know. I looked it up last year, I think, just to check. Everyone pronounces it a little bit differently, but really what an ogive is a cumulative frequency graph. Okay, so it's a graph with joining points, and those points represent the cumulative frequency of the data. So we'll look at that in more detail, but that's really what an ogive is. So just to remind you what we did last week, a group of data can be divided into 4 groups by finding the quartiles. Quartiles are the 3 values that are 1/4, 2/4, or a half, that's like the median, and 3/4 of the way through the list of values when arranged in increasing order. The lower quartile is denoted by Q1, middle quartile Q2 or median, and the upper quartile is Q3. Then remember the interquartile range is in that box plot, the difference between the ends of the box, okay, Q3 minus Q1. So determining quartiles from a small data set, it says determine the lower extreme, lower quartile, median, upper extreme, and so on. Okay, it's small, so we can do this one by hand. Okay. Now, what you might want to do, if you're doing it by hand, do you have to even put them in order? If it's small enough, not really, you have to count them in order. But first of all, find out how many data values there are. So count up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So sometimes we call that n. N is the number of data values, is 17. Okay, so if we think about that, our median is going to be the, what is that? So if we divide that by 2, that's 8.5. So it's going to be the 9th data value when it's in order. Okay, so that means there's 8 data values below. Okay, so quartile 1 will be the average of the 4th and 5th data value. Quartile 3 will be the average of the, so 9, so 10, 11, 12, 13, and 14 data values. Okay, so if we list them in order here, or go through them in order, smallest is 3.1. I want to look for the 4th and 5th. So 3.1, 4.2, 4.2. Next one is 5.7. So that's going to be 5.7 and 6.2. Okay, median is the 9th, so we just got to the 5th, then 6th, 7th, 8th, 9th, so that's 7.5, okay, then 10th, 11th, 12th, 13th, and 14th, and divide by 2. And then 15th, 16th, 17th. Yep. Okay, so now you can find those. If you feel it's easier to write them all out in order and then look and go for it. But for a small number, you should be able to do that. You can always check by using your calculator, and we'll do that in a minute. So here, well, you can do this in your head, but anyway. So 5.7 plus 6.2, and then divide by 2, so 5.95, and this would be, what, 4.15, oops, 8.15. Okay. So, to construct a dot plot, or a box plot, so our lowest value was 4.2. Oh yeah, I didn't actually list it there. So lowest extreme is 4.2, and highest or upper is 9.4. Okay, so take a look at the scale. It's each marking is 0.5, so 4.2 would be about there. Quartile 1 is almost 6. Median is 7.5. Quartile 3, 8.15, so about there. And upper is 9.4. Okay. So there's one whisker, then make the box. Whisker. Okay. And then use your calculator to do it. So remember, what's up? Oh, did I miss it? Oh, 3.1. It is. Thank you. Okay, so go here, 3.1 to about there. Thank you. There we go. Okay. So you would have found it, I would have found my mistake if I put it in my calculator. Always go back. I mean, I missed that, so that can happen. You want to check your entries. So I'm going to clear off any lists that I have, and you can just enter them. What's nice in your calculator is you can just enter in whatever order they were given to you. Okay, so notice here, it's on the 18th entry, there's nothing in there, which means I've entered 17 data values. So I know that I'm supposed to have 17, so hopefully I entered them correctly. If you quit out of that, it says to graph it with a box plot, let's just do that one variable stats, because that's really helpful for us. So if we go stat, let's do that first, just to check our values. So calc one variable stats. Now here, it's just a single list, so L1, and then we clear off L2. Frequency, leave it blank, calculate. Okay, and then we'll look at minimum 3.1, quartile 1, 5.95, which is what we got, median 7.5, quartile 3, 8.15, maximum 9.4. Okay, so you can check that. If you want to graph it, so go to second y equals. Take a look at your plot. We did this on Friday, so it's still entered in there, unless you cleared your calculator. So choose the box plot that has a little dot afterwards so that it could calculate the outliers if you needed to. And frequency list in L1, frequency is just going one of each of them. And it shows blue, whatever markings you want. It's on. So you can quit out of that. You can take a look in your, if you go to y equals, if you're going to do some kind of stat plot, it's going to be selected, right? So if now I decided, oh, I want to graph a quadratic, and I put it in there, it might have a conflict. So you want to deselect that if you were, say, switching to, say you're reviewing for the Q, and you're doing something to do with quadratics tonight, and you still have that stat plot in there, it might give you an error. So go up and deselect it if that's the case. In any case, now if I press graph, take a look. Hard to see. Why do you think that is? What do I need to look at? Video? The window. Yeah. Okay, so I went to 100 because we were doing one yesterday. So let's go from, let's see, that goes from 2.5 to 10.5. So 2.5 to 10.5, and it goes up by 0.5s. And then remember, for the y's, it doesn't really matter much, if at all. So there, if I graph, now you can see. Okay, and you can trace through that. So trace will go minimum, cursor to the right to the Q1, median, Q3, maximum. Okay. All right, so interquartile range will be Q3, which is 8.15 minus Q1, which is 5.95. So that's going to be 62.2. And then determine if there's no outliers. Just change my. Okay, so I want to take 1.5 times 2.2 times the interquartile range. Okay. So if you do it here, you might do this all in one step. 8.15 minus 5.95. Okay. Multiply by 1.5. That's 3.3. Okay. So now I need to go to my quartile 1 and subtract 3.3. So quartile 1 was 5.95, subtract 3.3. I'll put it in this 5.95, subtract 3.3 is 2.65. And you make sure that none of your values, or just check, are there any values that are less than 2.65? No. The smallest is 3.1. So there's no outliers at the low end. Then quartile 3 plus 3.3. So 8.15 plus 3.3 is 11.45, and we don't have any that are bigger than that. Okay, so there are no outliers. Okay, so what happens if we have an chart with intervals? Okay, so we don't have all the exact values, because the more values you have, it's going to be really onerous to have them all separate values. And so if we want trends in the data, we can group them together like we talked about last week. So estimating quartiles, we can't get the exact when we have intervals, but we can certainly estimate them. So when dealing with a large set of data that has been organized into a frequency table, we use a cumulative frequency curve, or ogive, to estimate the quartiles. So the number of customers for a movie theater was recorded every day for 200 days. Okay, the table below shows the results. So on a certain day, they check how many customers were there. So on 2 of the days, there were between 1 and 10 customers. On 8 of the days, there were between 11 and 20 customers. On 18 of the days, there were between 21 and 30 customers. Okay, so that's what this data represents. So the results are there. It says find the cumulative frequencies and use these and the upper boundary of each interval to draw an ogive, okay, or a cumulative frequency curve. So we're using the upper interval. That means this will be the data value that we plot to frequency for, right, of 2. So we're going to use the upper boundary. In any case, let's start. Cumulative, just like your cumulative exam, it's on everything, right? So cumulative frequency for the first is just 2. For 11 to 20, well, the cumulative frequency is everything since the beginning. So 2 plus 8 is 10. Then here, 10 plus 18 is 28. And 28 plus 22 is 50. 50 plus 64 is 114. 114 plus 46 is 160. 160 plus 20 is 180. And 80 plus 18 is 198. Plus 2 is 200. Okay? Makes sense because we're told they recorded this data for 200 days. So our frequency, total of our frequency should be 200. Okay. All right, so turn over, and you may have to flip a little bit. I'm just going to change my view here. Okay, so scale has been started for you. Okay, so take a look, it's going up by 20s vertically. If you say squish it down and you start, say it starts at 50 and you go up by 20s, you've got to do a little zigzag. But here it's going up by 20s. If your writing is really big, then you can go up every 2 and go up by 40. So that would be 80. And then 120, 160, and 200. Okay. So I'm going to do that just because it is a little bit small. Then these ones here, it started for you. It's going up by 10s. So then every 2 would be going up by 20s. Oh, let me do this. Just a sec. Okay. 40, 50, 60, 80. There we go. Okay. Really, our interval, our last one goes up to 90. So I don't really need the 100 there. Okay. All right, so this is going to be number of customers. And this is cumulative frequency. Okay, so graphing, it says we're going to use the upper boundary. So for the first interval at 10, we're going to plot 2. So it's pretty close to the bottom there, right? Okay. And then at 20, we're going to plot the cumulative, which is 10, so that's halfway. And then at 30, 28 would be about here. At 40, 50 would be halfway. And then 50 would be 114. So that's, what's that, 100. And then 14 would be about there. 60 would be 160. And then 70 would be 180. And 80 would be 198. And 90 would be 200. Okay? And we join them up with straight lines. Okay? So, let's see if this is going to cooperate with me. A little bit. Okay. Okay, so it looks something like that. So now we're going to use that. I mean, if you have the table of values, you can answer some of the questions, but you need the graph to help you with others. You're estimating. So it says here, or it reminds you that there's 200 data values. Q1 is the boundary for the lowest quartile of the data. So that means if you divide 200 data values into 4, there's 50 data values in each quarter, right, of a box plot. For the whisker, there's 50 data values, the first part of the box, second part, etc. Okay, so Q1 is going to be the 50th value. So here, Q1 is the 50th value, the median would be then the 100th value, because there's 200 data values in total. Q3 would be the 150th data value. Okay? So now let's actually find those values. Okay, so we need to look at the frequency here. So the 50th value, if we take a look here, so 50 is approximately there. That's an exact plot. You take a look here, cumulative frequency of 50, okay? And so we plotted with an x value of 40. You go across, you can see 40. So that's going to be 40. Yes, it's in an interval, but we have to, our estimation is that we're using that last value there, okay? Median is the 100th data value, so you go 100 there. Notice how it's not a point that we plotted, so we're going to estimate. So then we go down here. So it's going to be a little less than 50, so I'd say maybe 48. Right, because it's the 100th, so it's somewhere in this interval here. Okay. Then Q3 is the 150th. So that would be here. Again, we're going to estimate. Go down maybe about 58. And again, here, 150th, it's going to be in this interval. Okay, the interquartile range then would be approximately 18. Q3 minus Q1. Okay, so those are quartiles. Now we're going to get more specific or more values called percentiles. You've probably heard people talk about percentiles before, certainly with certain exams that you might write as you get older. Maybe you might write like an MCAT to go to med school, a GMAT to go to graduate school, an SAT. You're looking for, sometimes it's a raw score, sometimes it's looking for the percentile ranking. Okay, you want to be in the, if you have a top, let's say top 90 percentile, that means you are scored higher than 90% of the people that wrote that test. Okay, if you scored, say, the 30th percentile, then there's only 30% of the people that scored lower than you. Okay, that's what a percentile means. Sometimes, if you have any little brothers or sisters, when they're babies, they measure their length, like the height. I mean, they're lying down because they're babies, they're not walking, but their length, their weight, and they rank them in terms of percentiles. So a baby's weight is in the 80th percentile, means that there's 80% of the babies of that age weigh less than them, and 20% weigh more. Okay? Yes?
So would that mean that the 50 would be like average?
If, yeah. It would be a median, right? 50th percentile is the same as the median value. Not the average. Average is you add them up and divide by it. Okay, but it would be the same as a median value, the middle value. Okay, so let's take a look at percentiles here. So we may need our graph or the chart. So a value is in the nth percentile, denoted by a capital P and a little subscript, not to be confused with probability that we'll talk about later. Probability doesn't use a subscript. So it's denoted by P subscript n if it is greater than n% of the data. For example, the median is 50th percentile and denoted by P50. So P50 is the same as the median, which is the same as quartile 2. So there's 3 different ways of stating what the notation for median. First quartile is the 25th percentile. So P25 is the same as Q1. Okay. Use the above ogive to estimate each of the following percentiles. So percentile 10th percentile. So we want to look, that means 10% of the data. We've got 200 data values. So 10% of 200 is 20th. So we want the 20th value. Okay, so let's take a look. 20th value, we go up there and across, it looks to be about 25. Okay. 35th percentile, that means 35% of the 200 data values, so that would be the 70th value. Okay. So we look at the 70th, so that's 60, 70 would be halfway in between. We go down, I would say that's about 50, about 44. So if this is on a test, then we will take sort of a little bit of leeway in terms of the answers, like plus or minus 1 or 2 each way, but not more than that. There's got to be you've got to be pretty close. Okay, so then the 60th percentile is the 120th value. So that, if I go across to 120 and go down, that's going to be 50, I don't know, maybe 52 or 53. And the 95th percentile, that would be the 190th value. Okay, so 190th value. So that's 180, 190th is about there. So I'd say about 78. Okay, now use the above ogive to estimate the percentile ranking of each of the following. Guys. Okay, so we want to see the value of 10. So that's 10 customers going into the movie theater. What percentile ranking is that? So now we're starting at the X value. Okay, and we actually graphed that, right? That's 10. So that had a frequency of 2 out of 200. As a percent is going to be 1%. Actually, I'm running out of space here. So that's going to be P1. I'm just going to convert it right away. Okay, so 10 equals P1. So I actually put that up higher. Okay. 25. So that's halfway in between. It looks to be cumulative frequency of about 20. So 20 over 200. Okay, that's going to be percentile of 10. There we go. Okay, 50. 50 was actually a value that we got from our chart, 114. Right, so if you look here, it's a chart. It's on an actual point, 114 out of 200. So the percentile of that is 57. And 70 is also an exact value, 180. So that's going to be 180 out of 200, which is 90th percentile. Okay, and then last, use the box plot from question 1, okay, to determine the following percentile. So remember, 25th percentile here is the same as Q1. So Q1 was 5.9, oops, wrong. 5.95. '50th percentile is the median. Guys, just quiet for 2 more minutes. So 50th percentile is the median, and that was 7.5. 75th percentile is Q3, and that was 8.15. Then you have practice. Okay? Practice or review for your Q.